So hello everyone and welcome to this EBI webinar. So this PDBe webinar will give you an introduction to macromolecular structure visualization at the PDBe, and this is using the new Lite Mol viewer at our website. If you do want more information about our services or you want to get in contact with us, there are some links at the right hand side of this slide here. There's also an icon here to display our YouTube channel, and this webinar will be made available on our YouTube channel as well as on the EBI training pages. So for those of you who might be unfamiliar with the different PDB data centers, I thought I'd just explain what the Worldwide Protein Data Bank, the wwPDB, is. So it's actually composed of 3 separate regional data centers. So there is the RCSB PDB in the US, there's ourselves PDBe, who are based in the UK, and PDBJ, who are based in Japan. And though there are 3 different data centers, actually we all work together on deposition and annotation and archiving of this data. So we'll work on this one deposition portal. Data comes into us, is annotated in the same way and goes into a single PDB archive. The difference then comes in the way that we serve the data afterwards. So we each have distinct websites, and we have other tools, different tools and ways to analyze the structural data. So in this webinar, I'll be focusing on the visualization tools that we have available at the PDBe at pdbe.org. Litemol is a new viewer, and it's designed to visualize macromolecular structures quickly and easily online. So it's been developed by David Senal at Scitech in Brno. He's the man on the left here. And he's been working alongside my colleague Mandar from the PDBe in order to create this viewer. And what it is it's a browser-based online structure viewer. It's very lightweight, and the emphasis is really on the speed of use. However, because of the links to us at PDBe, there's also a lot of additional features that we've been able to incorporate into the viewer. Something else that David has worked on is the coordinate server. This is an added extra onto Litemol, and it is improving the speed even further by only serving you data that you need and speeding things up even further. So why might you want to use Litemol? Well, there's obviously a plethora of different structure viewers, and there are a number of desktop structure viewers that are very powerful, putting programs like PyMol, Coot, and Chimera. And the main problem with these are that they aren't web-based. These require download into your desktop. There are, however, a lot of online structure viewers. You have things like JSMol, MolMil, and NGL. Often these have a very specific function. They do a particular job well. Usually they rarely handle very large structures. So what Litemol aims to do is fill in this gap to enable you to do a range of different things with your structure viewing and handle very large structures in an online viewer. So as I've said, Litemol is fast, and it's also interactive, and you can use this within your browser very easily. There are a number of different options for visualization. So you can view polymers in the common model views that you'd see in other visualization software. You can view it in cartoons, surface, ball and stick, and other modes like this. We also have a number of additional annotations on top of this. You can view assemblies as a structure instead of the asymmetric unit. You can also see symmetry, and we also have other structure annotations such as validation and family domains in there as well. We also have the option to display density maps for X-ray crystallography entries, and also display cryo-EM data on your structure. Mainly we use PDB entries, but if you want to load your own MMSIF file, you can do this through Litemol as well. There is also the option to integrate Litemol into your own website as well. The coordinate server is something else that has been developed alongside Litemol, and this is another added improvement on Litemol to add real-time delivery to what you're seeing. So it only takes the bits of the molecule that you want to look at and displays them for you. And if you want to find out more about how you could use the coordinate server, for instance, at looking at ligand binding sites, you can see this at pdbe.org. I'd just like to illustrate how Litemol handles large structures with this video example here. So this is entry 4V88, which has 2 ribosomes in the asymmetric unit, which is a really, really big structure. So this is loading over 400,000 atoms and doing this directly in your browser. As you can see, it's already loaded it up, and that took less than 10 seconds for context, I did the same using the fetch command in PyMol, and it took 16 seconds. And I also tried it in Chimera, and the program actually crashed. So this shows how well Lite Mol is handling these large structures. Lite Mol is simple to use, and generally it will follow the style of most other structure viewers. If you want to access Lite Mol, you can go to pdbe.org and navigate to a specific entry page. If you then click on the 3D visualization link, this will bring up Lite Mol for you to view the structure. The controls of the mouse are very basic. If you want to select a particular residue, you can highlight it. You can see with the mouse hovered over it, and then click on this residue, and it will center around this residue and the corresponding region. If you hold the left mouse button, you can rotate around and change your view with the rotation. Holding down the right mouse button enables you to zoom in and out of your structure. And you can also move your structure along the plane of the view by holding in the mouse wheel and moving your mouse. If you want to use slabbing, and this will enable you to see different levels of what you're seeing in the structure, you use the mouse wheel rolling of the mouse wheel in and out to change this. Another great thing with Lite Mol is we've optimized it for tablets and phones on touchscreens as well. So if you tap on the screen on a residue, this will center around that residue. You can also use a single finger gesture in order to rotate around the structure. If you want to zoom in and out, you can use the pinch gesture, which will be very common to you from using touchscreens, and this will zoom in and out of the structure. And if you use two fingers together dragged along the screen, this will move the structure around in the plane. There is again the option to do slabbing, and if you use three fingers sliding up and down the screen, this will change the amount of slabbing shown in the structure. There are also a number of basic settings that you can set. If you go up to the top here, this is the settings option for field of view. This changes the perspective of your view and gives you a different view of what you're seeing in the structure. What you can also do is change the background as well. If you click on the background palette here, you have a number of colors to choose from. And if you wanted to make figures, there is also a camera button at the top, which enables you to then take a snapshot of what you're seeing. These three sections on the right here control the view of your polymers, your ligands, and your waters. The I buttons on the side here will enable you to toggle on and off any of these views. So this ligand is toggled on and off. We can also remove the waters if you're not interested in them. What we have now is the polymer shown in cartoon form and the ligand shown in ball and stick. And it may be you want to change the type of view you're seeing for your polymer. You can change the type from cartoon here to ball and stick. And you can also change the coloring to element symbol. So you have a lot of flexibility for visualization of your entry. One major benefit of Lite Mol at the PDBe is the ability to view electron density maps for X-ray crystallography entries. This is thanks to EDS, which is now hosted at the PDBe. So if you open Lite Mol for an X-ray crystallography entry, you can then click on a residue, and this will display the density around this region. There are three types of density maps that we view. So the blue map shown here is the 2FO minus FC density, and generally this should surround your atoms. There's also negative and positive density shown in red and green, and this highlights where there might be extra or missing atoms in your structure. So for instance, with this example here, we have a tryptophan residue. There is a region of negative density around the carbon and nitrogen of the tryptophan, while there's regions of positive green density on the other side of the ring. And this suggests that these atoms that are at the top should actually instead be positioned at the bottom. And as you could probably see, if you were to flip that tryptophan around, this would satisfy the density. So these are things to bear in mind when you're looking at structures is, does my density match what I'm seeing in the structure? And here's a quick video to show you how this works. So if you go with your mouse and you click on a particular residue, this will zoom in around this region and automatically generate density for this entry in a 5 angstrom radius. There are more options for toggling your density maps here. If you use the I symbol on the side, this will toggle your density on and off. You can also open the color area, and you can show wireframe if you wish to, and change the colors of your maps if you wish to as well. There's also a number of controls for your negative and positive density, Again, you can toggle these on and off using the I symbols. You can also change the ISO value for these maps as well if you wish. You can also navigate around the structure, and as you do so, clicking on a residue, this will then recalculate the density around this region. So you can browse easily throughout structure with this density being recalculated as you go. Opening Litemol from a PDBe entry page gives you a number of options for displaying extra annotations on your structure. So one thing we have is the ability to view the annotated assembly. So for X-ray crystallography entries, often what is in the asymmetric unit and what you see in the PDB entry doesn't actually represent the likely assembly for that entry. We record this annotated assembly in Annotation when the depositor gives us the structure, and you can then view this in Litemol. Another thing we do across the wwPDB is to produce validation reports for all new PDB structures. And within these, we produce color-coded graphics for all the proteins and showing the geometric quality outliers within the protein itself. The green residues in this case at the bottom along the bottom of the screen here, green represents there are no quality outliers, ranging to red, which means there are 3 or more model quality issues. These can be things like bond length, bond angle, Ramachandran outliers, or maybe too close contacts. So what we've done with Litemol is we've applied this information from the validation reports onto the structure. So if you click Apply under Validation Report in Litemol, this will then generate this on the structure, and you can see where the red and the orange parts are. This is where there are a number of outliers for these specific residues. Another thing that you could show within Litemol is domain annotation as well. So we get this from databases such as PFAM, Interpro, and Cath and SCOP, and you can select specific domains within this entry and apply them, and these will be highlighted in orange in the structure, so you can get a clear idea of where these exist. Here's a quick video showing you how you can view some of these annotations. So if you want to look at the assembly, you go to Source and select Assembly, and then click Apply, and this will apply that assembly to your structure. So now what you're seeing, rather than the asymmetric unit, is the actual annotated assembly and a better representation of what's there. You can also apply the validation report by clicking Apply here on the right, and this will color the structure by the validation report. If you then hover over a particular residue with issues, these will then be shown in the top left, for instance, the clashes and the bond length outliers. You can also add domain annotation. So for this example, I'm going to choose a PFAM domain. This is a histidine kinase domain. If you apply this to the structure, this will then be highlighted on the structure and show you where this domain exists within the structure. Litemol has been incorporated into the PDB ligand pages for entries in the PDB. So if you want to access ligand pages, if you navigate to an entry at pdbe.org, in the ligands and environments section, all these ligands are listed. You can then click through to one of these, and this will take you through to the page for that specific ligand in that specific entry. You get a number of pages about number of information about the ligand there. If you want to look at a different instance of that same ligand in the structure, there's the option to change this using this box here. We also give 2 different views of the binding site in a 2D representation on the bottom left, and also in Litemol with the structure and density shown. So here's an example of how you might assess ligands using Litemol. So for this entry 3IAZ and the ligand AIN, you can see that in the Litemol viewer, there's a lot of red density surrounding this ligand. Now this suggests that there's not much data to back up the modeling of this ligand. So this is something important to bear in mind when you're looking at ligands. If you look at these through our pages, you can get a good idea if what you're looking at is fits the validation. You can have some confidence then on what you're looking at. You can view all sequence annotation interactively along with the structure at the PDBe using Litemol. So if you want to access the pages for a specific macromolecule, if you navigate to the entry page and move down to the structure analysis section at the bottom left, there will be information for a specific macromolecule in that entry. If you click on the molecule details, this will then link out to our sequence to structure page, And this gives you three views. One of them is your sequence. You also have a 2D topology diagram which shows you the secondary structure linkages. And there's also a 3D viewer with Lite Mol to show you what the 3D structure looks like. And all of these are intrinsically linked. If you do what I've done here and you hover over a helix within the sequence annotation, this will also be highlighted in the 2D and the 3D structure as well. So here's an example of how this works interactively. So as I said before, we have the sequence, the 2D, and the structure here. At the top of the page is the sequence part with a lot of annotations shown here. And if you were to hover over any of these, for instance, the uniprot entry, this will then be highlighted on the other, on the 2D and the structure, as will the PFAM domain as shown here. If you select particular residues for the chain, you can see that these are highlighted on the 2D and the 3D structure as well. And above this bar, there are also these green triangles, and these indicate where these residues are involved in binding particular ligands. Again, below this bar, you have a quality bar, and this is linked to our validation reports, with red showing particularly a large number of outliers. And again, this is all interactively linked. And you can also show this in the 2D topology diagram by navigating here to quality, and this will show it on this picture here. And this can also be set in Lite Mol if you open the tools and click on apply for validation report. As I said before, they're all interactively linked, and if you click on a specific thing, for instance here we have an issue with data, the model not quite fitting the data, we click on that and it will take us to that residue in the 3D structure. If you click again on that cartoon representation, this will open out the density in this view. And you can see here that there's a lot of red density surrounding this residue, suggesting that there isn't much data to back up where this residue has been modeled. However, there is another section of green density which suggests that there are atoms missing from this point. It may be that the depositor has instead modeled this in the incorrect place. For electron microscopy entries, you can use Lite Mol to also view the EM map along with the structure. So to access Lite Mol for an EM entry, you navigate to the entry at PDBe.org, and this electron microscopy entry is 5GAQ. If you click on the 3D visualization link, this will open up Lite Mol. So for EM models which have an associated map in the EMDB, this is now a mandatory requirement for new EM-PDB depositions. This will automatically show you a map. There will be some cases with large maps where you may require acceptance of the map download, and this will be shown at the bottom of Lite Mol. However, we are trying to improve this service, and hopefully soon these will automatically all load. You can also control a number of views using the density box as well, and the ISO value here represents the contour level, so you can control that as well. So here is an example of viewing EM data using Lite Mol. If you click on 3D visualization, this will open up the Lite Mol window. The structure will load initially, and then the map will also load afterwards. You can then interactively view all of these together with the map around the structure. As you can see here, the structure fits very well into the map that we've got. There are also a number of extra controls you can add on the right-hand side. For instance, if you wanted to apply a validation report, you could do this using this button here. If you want to control the density or maybe turn off the map, you can do this using the I button. There's also the option to change the view of the polymer as well. If you do want to get a closer look at the structure, you might want to navigate to a specific residue. You can do this interactively by clicking, and this will center the viewer around this area. And you can then view the structure within the map. And if you click between different residues, this will reorient your view around that particular residue. The PDBe has built up a library of web components that can easily be integrated into your browser, and that is the PDBe components library. So there are a number of components available for this integration. This includes Lite Mol, and you can easily integrate this into your browser. There's also some components such as PDB links, which offers links to all wwPDB sites. There's a sequence feature view, which shows our 1D, 2D, and 3D representations. There's also some external components, such as our Regini PDB residue interactions browser, and there are many more there. If you want to find out more about the components, if you go to our homepage at pdbe.org, And on the right-hand side, there's a popular links section, and you can select the PDB component library. So if you wanted to put Litemol on your website, you would download the PDBe components library, and this is 3 simple steps to download this to your website. You can then use the elements that are shown at the bottom of the page, put these within your website, and this will enable you to use the individual components. There are much more in the PDB components library. For instance, the PDB links on the left-hand side. If you want to put a link out or want to offer people the chance to choose whichever of the PDB sites they wish, you can put this component in, and this will offer you a link to each of the websites from here. There's also a PDB redo component. PDB redo is an external service that re-refines structures, and what we offer is a validation slider which tells you whether PDB redo has done a better or worse job of the refinement. This is an automated redo service, and we now show this on our pages, all our pages that redo has been functioning for. We also have another external component, this Regini browser on the right-hand side, and this shows you residue interactions between secondary structure. And again, this is an external component that we've incorporated into our library. So in conclusion to this webinar, Litemol is fast, and it's hopefully a very simple to use browser and a visualization tool within your browser. We think that it's a great way to get a chance to understand the structure quickly without needing to go too in-depth, without having to download the files and view it that way. Another bonus is the option to view the data that supports the model, and this gives you more of a chance to validate what you're seeing. It can also be easily embedded into other websites if you want to use it for your own purposes. So thank you very much for your attention to this webinar. There aren't any questions that we've come across so far, but if you do have any questions, these links are here again for you to get in contact with us, either our email address at pdbhelp@ebi.ac.uk. You can follow us on Twitter at PDB Europe, like us on Facebook, and also look for us on YouTube, where you hopefully will find this webinar very soon. And please share the webinar with friends as well, if anyone you think might find this useful.